Hello friend, welcome to Data Laksh. In the last video, we have discussed about the introduction to machine learning. Now, next we have regression topic in the given syllabus. So, what is the regression? We can say regression. A regression problem is a problem of determining a relation between the one or more independent variable. So here we have one or more independent variable and a continuous output variable here. So you can see from in this figure, this is the figure for the y equal to mx plus c, or in other term you can say y equal to a plus bx. So this is the case for the linear regression, and we have multiple type of regression model. So this is the specific for the linear regression. So here we have one is uh, independent variable. So this is the independent variable, and we have next is the dependent output. So this is the, we can say, dependent variable. So this value is continuous output, we get a continuous output variable, right? So this is also variable, and this is the in continuous nature. So if you see this line, this is the continuous output model here, we can say. So in mathematical term, we can say a relation between the x and y containing set of parameter theta in the following form. So here we can say in this equation, for example, as we have y equal to mx plus c. So see here, m is here certain parameter, and we can write also in term of theta also, right here. And c is the, in this case, c is the intercepting point here from on the y axis, right here. So in general case, for every regression model, we can represent like this one, y equal to g of x, comma theta. So x is the dependent variable and theta is the certain parameter here. And so this is the y equal to g of x comma theta here. And this is the this function g of x comma theta. This is known as the regression function, right? So this is the regression function here. Now let us say application of this regression model. So there are a lot of application in this machine learning and or another we can say domain. So if in case of machine learning, we use for the car price prediction. For example, in this case x, we have input variable. So if this is the input variable x, so we assume input, for example, brand, year, uh, engine model or engine capacity, mileage, etc. So this is the input variable, and with respect to this, what we get? The price of the car. So what we get? Output price of the car here, right? Similarly, for the autonomous car navigation system. So in autonomous car navigation system, we have input variable. For example, we can say video camera, GPS, sensor, etc. So this is the input variable, and with respect to this, we get the steering wheel in angle right here. So at what angle the car should turn, or like this one. So we get the output in this form. Similarly, we get another application in the finance area. For example, capital asset pricing model for the analyzing systematic risk, and in if you see economics, so predicting the consumption spending, labor demand, etc. So there are many application of the regression model in the different domain. So these are the certain example for the regression. If you see the regression model, as I said, there are different regression model we have. So mostly we use the linear regression model, multiple regression model, or we can say polynomial regression, logistic regression. Now let us see one by one in the a simple form, or we can say uh, uh, in uh, simple way. Okay? Right. So the different regression model are defined based on the type of function used to represent the relationship between the dependent variable y and the independent variables. Uh, for example, we have here simple regression model. So in case of simple regression model, we have only one independent variable x, and if the regression and this is the relation between the x and the y modeled by this relation y equal to ax a plus bx, where uh, A and B are the certain constant, and X and Y are the variable. And X here, as we have discussed, X is the dependent variable and Y is the X is the independent variable and Y is the dependent variable here. So this is the simple regression model. Now we have multiple regression. So in case of multiple regression, we have more than one independent variable. For example, we have x1, x2, xn, and in that case, we'll get the relation between the this independent variable and the dependent variable y right here. So we can say here y equal to alpha naught plus alpha 1 x1 plus dot dot alpha n xn. So this is the multiple regression model here we have. So then, as it says, then it is the case of multiple regression model, or we can say multiple regression. Next, we have polynomial regression. So in this case of in case of polynomial regression, uh, we have only one variable x, and let the relation between y model as the y equal to alpha naught plus alpha 1 x and plus alpha 2 x square plus dot dot alpha n x n. So here we have um, in term of power right here. That means polynomial means we have in this form uh, x square plus x cube right plus dot dot x n. That means we have higher degree variable here. So for some positive integer n greater than n, then we have like this one, we have polynomial regression. So if the general case like this one, that means we have polynomial regression. Next one we have logistic regression. So mostly this is not a regression model, but we also use this is the regression. Here we have uh, dependent variable in case of binary nature. So logistic regression use when the dependent variable in this form either 0 or 1 or true or false or yes or no type right here. So in this case, we say this is the logistic regression. Even though the output is binary variable, what is being sought to be is a probability function which may take as a value from 0 to 1. Right. So in this case, our value may be from 0 to 1 also in case of output. So this is the logistic regression. That means we have input variable in term of either 0 and 1 or true or false or yes or no type. So that in that case, our model will be uh, called as the logistic regression. Now let us see simple regression model in some detail way, and we will also do a certain uh, problem on this simple regression model. As the in the if you see in the syllabus, get IIT get DA paper in the machine learning. So we'll get certain problem also in the our paper. So this is very much important with that respect too. So as we have discussed, this is the y equal to alpha plus beta x. So if we have this model, then we can say this is the simple regression model as we have also discussed here. So this is the alpha x is the dependent variable and y is the independent variable, right? These are written in this one. So what it say further? In order to determine the optimal estimate value of alpha and beta, so we have to also find the alpha and beta. And in exam, this also they ask what is the value of alpha or in another term what they ask y equal to a plus bx. So they ask what is the value of a and what is the value of b, right? So this is the very much important for the in the problem solving. So be ready to find the value of n b. So an estimate method known as the OLS, that is the ordinary least square method. So this is the used to find the a value of a and b, right? Now let us see how we can find this one. So we use this formula to find the a and b. So, first we have find the average of, as we let's see, this is the we have xi, and with respect to we have output yi, and we have x1 x2 x3 dot dot is like this one, and with respect to x1 we'll get the certain value y1 y2 like this one. So first we will find the average of this input variable. So we'll get the x bar equal to 1 upon n summation of xi, and similarly we will get the average of y. So in that case we will use this formula right here. When we find the average, further we also find the variance of x right here. So for that case, what we know the variance, in case of variance, we have average value. Let this the average, this is the average point x, and with respect to average, we find the distance of each point, right? X1, x2, x3, right? This is the average. From this average point, we find the distance of each point, and we square the that distance, and we sum that for the value, and divide by n minus 1 right here. So this is the formula for the variance. Variance of x equal to 1 minus n minus 1 summation of xi minus x bar. The x bar is, that is the this mean value of x and whole square. So this is the variance, and further we'll find the also covariance. So covariance of x, that means the relation between the or we can say variance between the x and y, and this is the denoted by covariance of x and y, and this is the defined as covariance of x comma y 1 upon n minus 1 summation of xi minus x bar, and similarly for the value of output, we find the yi minus y bar. So this is the formula for the covariance of x comma y. And to find the a and b, as we said, a and b, what we use? We use this formula. So v equal to covariance of x comma y upon variance of x. And when we find the value of b and x and y, we put this value of average of x and y, and x bar, y bar. We put this value in this formula. So we'll get the a also right here. Now let us see with the given example. So what is here say example, obtain a linear regression for a given data assuming that y is the independent variable. So here given is x is given 1, 2, 3, 4, 5. This is the point of x, and with respect to x we have output value y is 1, with respect to 2, 2, and with respect to 3 we have 1.3, and with respect to 4 we have 3.75, and with respect to 5 we have 2.25, right? So this is the value of y, and this is the x. First, what we do first? How many numbers? How many variable? How many input here? So number of input we have n equal to 5. Now what we'll find here? X bar, and what we know? X bar equal to n minus 1. X minus 1, or we can say here if you see in this formula 1 upon n. Sorry, here 1 upon n. So we use 1 upon n. N upon n summation of xi right here. This will be 1 upon 5, and 1 plus 1 plus 2 plus 3 plus 4 plus 5. This will result x bar equal to 3 right here. Similarly, for the y bar 1 upon n summation of yi right here. So we use this one. So from this we will get the value y bar equal to 2.06. And if you see formula next, so in this next step, what we have to do, we have to find the variance and covariance right here. So now let us see what is the variance here. So variance, first we can find also covariance or variance. So for covariance, we use formula 1 upon n minus 1 summation of uh, x minus xi minus x bar whole square, right? So by using this formula, we will find the this is the for the variance. So this is the for the variance. We have used here 1 by 4 1 minus 3 whole square plus dot this one, right? So by using this formula you get the value of variance of x equal to, so variance of x equal to we have 2.5. Now further we use covariance of x comma y. So the formula of this one, as we know, 1 upon n minus 1 and summation of xi minus x bar and yi minus y bar right here. So using this formula, here we get the value of covariance of x comma y 1.0625 right here. Now, next, what we apply the find the value of b. So, what we know in case of b, here we have b. What is the b? Covariance of x comma y upon variance of x. Now, use this formula. What we will get here? B equal to this by this covariance of x comma y upon variance of x. So, this value will be 0.425 right here. Now what you have to do? What we get here? We get x bar, y bar, and covariance of x. That means here we have what get here? X bar, y bar, and b here, right? B. Now putting these value in this equation right here. So when put this value in this equation, we will achieve here. We will get here a equal to uh, this value a equal to 0.785. So this is the b from here, or we can write here. This is the what? This is the not b here. If you see the formula y bar right here. So y bar minus bx. So y bar value is this value. Well, I think. If you see the formula, a equal to y bar minus bx. So if you see the y bar value here, see here, y bar will equal to 2.06. So put here 2.06 and b value here 0.42 here into x, and x bar equal to 3.0, and the resultant value will be equal to 0.785. Now put this value y equal to a plus bx right here. So when you put in this equation, we'll get here y equal to 0.785 and plus 0.25 x. So this is the answer for the linear regression model. So if you see the model here, so this is our model here, and this is the value of x1. This is the in this case for x1 we have y1, and this for y2 this is the this value, and this is the point hour, and with respect to x we have the value of y also right here. So this is our point, and we get this model. So this is the regression model, simple linear regression model here. So in this video, we have discussed about the regression, and in that case, what is the regression? Regression, further type of regression model, and most important is simple regression model. And we solve the certain one problem here on the basis of simple regression model. Right, simple regression model. So that's it from this video. If you find this video informative, please do like, share and subscribe this channel. Thanks for watching.